So for this example, we're going to be constructing a Simplex tableau from a linear programming problem. It says here, construct a Simplex tableau for the given objective function with the constraints. So this linear programming problem is known to be in standard form. And I'm just going to write it up here, standard form. And we know it's in standard form because of these 3 points. The first point is the objective function here, p is equal to 6x plus 5y. This objective function has to be maximized, and we know that it's a maximization objective function because it starts with p, and in the past sections we know that p stands for profit, and profits we want to maximize. So we're going to be using the variable p to represent an objective function that needs to be maximized. Another point is the decision variables. Those are the variables inside the body of the system here, 2x and 2y. They're all non-negative values, as you can see. And each one of the constraints here, 2x plus 2y is less than or equal to 1800. Each one of these constraints is less than or equal to a non-negative constant here. So now that all those 3 points have been met, we know that this linear programming problem is in standard form. So now that we know it's in standard form, the first thing we want to do is we want to rewrite the objective function here, where we want to have the variables all on one side of the equal sign. And we're just going to simply do that by subtracting the 6x and the 5y. So this is rewritten as negative 6x minus 5y plus p. That's going to be equal to 0. So now that we have that, the next thing we're going to do is we're going to rewrite the constraints of the system of inequalities as a system of equalities. But these equalities will include the objective function, and we're also going to introduce slack variables. And a slack variable takes up the slack between a point within a feasible set and a corresponding vertex. You could kind of think of a slack variable where it allows the linear equation to mimic a linear inequality. So we'll just write it right here. This will be 2x plus 2y, and then we have to introduce a slack variable, add in a slack variable. Now the slack variable really can be any variable, but we use the variables u, v, or a w. So I'm going to introduce the slack variable u, and then make this equal to 1800. We'll do the same for this next constraint here. X plus 3y. We'll add in a slack variable, but that slack variable's got to be different than this one. So we'll use v. That's equal to 3000. We'll do the next constraint here. 2x plus y. Introduce a slack variable, but it's got to be different than the other two. So we'll put in w. That's got to be equal to 2400. And finally, we're going to put in the objective function here. That's a negative 6x minus 5y plus p, and that's going to be equal to 0. So now that we have our linear equations here, now from here, we're going to build the tableau. Now, since we have more variables here, u, v, w, and p, so across the top of the matrix, we're just going to label each column x, y, u, v, w, and p. We just do that for clarity. So then we'll put in a bracket. Then we'll put in 2, 2, 1 for u. There is no v in this equation. There is no w, and there is no p. We can now put in our vertical line, and then 1800. For the next equation, 1, 3, v, there is no u, but there is a v. There's no w, and there's no p, and then 3000. The next equation, 2, 1, There's no U, there's no V, but there is a W, and there is no P, and then 2400. And then we'll put in our objective function here, -6, -5. There is no U, there is no V, there is no W, and there is a P, and then 0. And then we close off our bracket. We're going to put in one more line. We'll put in a line right across here. And we do that to separate the constraints up here from the objective function down here. But as you can see right across here, you can see this diagonal of 1s. So that should appear in your Simplex tableau when you first create it. But this is the Simplex tableau for this linear programming problem. And there we go.